Again, this is with you from Anexinet to talk about big data for Anexinet. And today I'm going to spend about 10 minutes again with you. And what I want to do is introduce you to a little bit about the technical side of Hadoop. I'm going to focus on Cloudera's distribution of Hadoop. So as you can see, I have my Linux VM up here and running. Let me actually clear some of this stuff out here. And I'll go back to the browser here and do it clear on this too. Go back to the creator. So I'm going to start you over from scratch on this quick demo on Hadoop. So just as a recap, Anexinet is a Philadelphia regional leading IT services provider, and we help you and partner with you, as well as our strategic technology partners, on big data. And one of our big data solutions is to help you to implement and to put together a roadmap and strategy around how to implement Hadoop for big data. And Cloudera is one of the most popular providers and distributions of Hadoop. And so this one is based in Linux. And I'm just going to introduce you to some of the concepts here. And, one of the important things to keep in mind is that in a big data platform, leveraging Hadoop is very important because it allows you to distribute very large, complex files into distributed blocks of data that are managed from a centralized node within the Hadoop cluster. So it's the ability to distribute data in a cluster, and allows you to work with data in parallel. And that whole mechanism to work with that data in parallel is called MapReduce. And the file system that handles the clusters and the distribution is called, in the distributing of the data, is called HDFS. So when you put a text file into HDFS, you end up with the distributed blocks across many nodes, and that gives you the ability to also grow and to scale linearly, so that you can add more nodes to create more processing ability within your cluster in your system. So I'm sitting here at the command prompts in a shell here on my Unix system, and let me do this. Let me start you with taking a look at just some very simple ways to access data in Hadoop. So here within my home directory, I have a very, very simple demo that I'm going to walk you through today, and I just created a sample text file called sample data here. As you can see, I just comma delimited a bunch of fields. I have an identifier for, let's say that's a purchase ID, the name of the person, a customer who made a purchase, the color of whatever product it was that they purchased, and a price on that, or a cost to the customer. And within Hadoop, what you want to do is you want to be able to get data, and I would say generally speaking within big data in general, you want to get data into the system as fast as possible. And that's one of the basic tenets of a NoSQL system as well, is that you don't worry too much about consistency and schema on write. You can apply a schema to that on read when you're ready to access that data, and consistency can come later within the life cycle of data. So the idea here is to get data in very fast. Now, obviously, your data files within a big data project with the next are going to be much, much larger than this. They're going to be, the scale is going to be terabytes, petabytes of data. That being said, this is a very simple 10-minute demo. So let's look at the file now. If I wanted to be able to analyze and query that data, I could create a schema on top of that, and I can allow my analysts and data scientists to have complex queries in the SQL language on top of that, which would be very nice. And there's a mechanism within the Hadoop framework to do that, and that's called Hive. So I'm going to focus on that in just a minute. But if I wanted to put that into a distributed file system, I could move that into what's known as HDFS, or the Hadoop distributed file system. And the way you do that is, one thing you want to do is you want to first create the directory structure in your Hadoop file system, so that it actually sits on as an overlay on top of your Linux operating system. And you can see that you have the same the same access rights and control over files and directories that you do in any Linux file system. This is a directory and has read, write, execute on it for owner, user, owner and group, and all the different mechanisms that you get within the Linux file system. And let me actually do this. Let's go ahead and look inside of that directory, and then I made one called Mark, and I put some files in there. Oops, that's F, not D. There you go. And as you can see, you get a when you run a command that's not recognized. I'm going to take this opportunity to actually have a learning experience with my goof there. you can see that you actually get a stack back from Java because the Hadoop file system is all written in Java. That's why. And so I put the file as well into my Hadoop file system. Well, what I'm going to do is I'm going to show you how to actually use that local file and load the data into Hive, which is the ability to put schema on top of that so that you're not just dealing with raw data and raw files, you now can have some queries that you can run in SQL on top of that. So what's interesting about Hive is that it's SQL-like. It's not actually conformant specifically to a SQL standard, but it's very, very familiar and comfortable to your users. And this is a web page that comes with the Cloudera distribution, and they call this Hue or beeswax. And anyways, the ability to be able to interface with the Hadoop system from this sort of a graphical interface is very helpful. There are also sort of, and I should say that each distribution of Hadoop, and same thing with the Hortonworks distribution, has a similar sort of web page and HTML access that's a little bit different, but same kind of thing. And you also get within Hadoop the ability to look at the health of your name node, which keeps in memory where all the blocks are stored in your distribution, and all the blocks are then stored in data nodes. In this very simple demo, this VM that I have for Cloudera, it's just one single VM, one node. Everything's running from here, so it's not really really distributed. So we call this pseudo mode. But you get all the data about your name node here. And of course, then you can also take a look at the job tracker, which will tell you about all the jobs running against that data within your Hadoop cluster. And I should say your HDFS cluster is probably more accurate. And so you can say I only have one node, but you can drill into that. And when these jobs run distributed across your file system within Hadoop, those jobs are what are known as MapReduce jobs. And they work with data that's locally on each node, which is the real power of Hadoop. So let's go back to Hue and back to the Hive editor, and I'll show you. Let me actually start. I think I have that table still there for my last iteration. Let's check if it's there. So I'm going to actually drop a table. I'm going to call it purchases. So purchases is the name of the table, the metadata I'm going to create to store that data from that sample file that I showed you. And let's see what happens. Okay, there we go. So now let's go ahead and let's recreate that table. So there's a little bit of difference here that you'll see from classic SQL. I don't need all this here. Let's cut out some of this. And you can see that you do create table, and I have field names, and I'm using an int and then 3 strings to hold the identifier, the name, color, and cost. But then I have to say, because this is schema later, I need to create a metadata set and then load it with data. So I need to tell Hive what the row format's going to be. And so I'm saying that I have the fields delimited by a comma, and each row or each line is delimited by a new line. So let's execute that, and then we should just have a plain table schema that will look and taste and smell a lot like a database table when your users access it. Okay, it was creative. There's of course no data in there. So let me drop out into the shell and actually show you the shell. So to get into Hive, you just type Hive. What I'm going to do now is I'm going to actually load that data file on my local directory into that table I created. I called the table purchases. So I just load that local data file into that table. And since I told Hive how the data is actually laid out in the file, that should work. And there you go. Now we can do things like this. Select star from purchases. And there you go. There's all your data that I showed you in the file. And then we can run this here from the query editor. Okay. And let that create that job for you and then run it. And there we go. Okay, beautiful. So this is a very small data set. Hopefully you've noticed that it's not super duper fast in terms of response time, and that is because Hadoop is, at its most basic level, a batch-oriented processing engine, and so it's not meant to be real-time access to the data. I can go into more detail on that in some later webinars, but I just want you to notice that, to be aware of that. But it's very good for processing very large, complex files that can be distributed across a cluster. and to manage that cluster for you. So there you can see now we could give access to a query editor like this, or a query editor window in Eclipse, or tools like ClipView, Tableau that all have drivers into Hive. Hive has a whole set of ODBC drivers and JDBC drivers you can download. You can even run these kind of Hive queries from Excel. So now your data scientists and your analysts have a great way to get to the data that you are processing and keeping at the most granular level within Hadoop, and allow them to run their own aggregations and queries and complex joins across that data. Last but not least, let's drop that table again just to show you that the syntax should be very similar to your DBAs and your developers within your organization. And let's see, boom, there we go. All right, so that was a real quick run through and a taste of Hadoop, and hopefully this was helpful to you, and I appreciate your time.